All right. Good morning, everybody, and welcome to episode number 3 of Learning Golang from Zero. My name is Paul Kernfeld, and I'm a member of the technical staff here at Cockroach Labs. Today, we're going to be learning some really basic Golang. Golang is the language that's used for pretty much everything here at Cockroach Labs. Before I started, I didn't know any Golang, and this is kind of working along with me as I learn the language. So, in the previous episode, we learned a bit about arrays and slices. Arrays and slices, in other languages, you might call them like similar to a list or a vec. They're for storing one-dimensional data contiguously. And while this sounds like a super basic thing to do, it's actually kind of complex, and I would say it's not really a solved problem in programming. There are a ton of different ways to represent one-dimensional contiguous data, and I think it's also really instructive to see how different languages choose to do it. So, yeah, let's go ahead and first we're going to kind of review the array and slice stuff that we learned previous episode, and then we're going to jump into whatever stuff I didn't get to yet in the book. And by the way, the book that I'm working from is called Learn Go with Tests. The reason that I chose this is because I wanted to have something that would both teach me Golang and have some exercises where I could practice it. I can learn, from a book, and I like books as well, but I wanted to make sure that I'm really testing my knowledge here. So, yeah, last time we wrote some tests, right? I remember we took the sum of a list of numbers. One thing that was really important in Golang is that we learned that there's this type with a brackets and a number inside of it, and this one is called an array, and an array has a length that has the length of an array is known and fixed at compile time. So it's actually the length 5 and the type int are baked into the type. And we talked about this a little last time, but it's a little mini kind of generic typing in Golang. Most of Golang does not do generic typing, but it is going to in a newer version of Golang. For anybody who's tuning into the chat, are people familiar already with Golang, or also like me, just starting to learn Golang? So here we wrote a test. This whole book is all about test-driven development. I think it's a really great philosophy for learning a language. The other thing that we learned here, we've got this other syntax, which is brackets and int 1, 2, 3. Himanshu says, good evening. Good evening, Himanshu. Yeah, it's 9 a.m. over here for me, but I think that actually my theory is that we don't have very many American viewers on this stream because, it's 9 a.m. on a Friday. I think programmers don't like to wake up early in the morning. So I think that probably most people here are going to be tuning in from Europe or Africa or Asia possibly. But definitely the Himanshu is tuning in from India. And yeah, Kajal says, I'm familiar with other programming languages. Yeah, that's great. What programming languages are you familiar with already? Personally, for me, I think it's mainly Python and Rust with little bits of Java, JavaScript, and, tiny bits of other languages. Kajal, I think you might be our first commenter on Periscope, so thank you for that. I don't really go on Periscope myself, Okay. Python, C, and C++. Well, I think that Golang is a really great. I think it's really interesting to compare Python to both C and sorry, it's let me try that again. It's interesting to compare Golang to Python and C because I think some of the actual aspects of the syntax look a little bit like Python. We kind of discussed that. Like if you're looking at this for loop, it looks a lot more like Python than C. But I think Golang is also inspired by C because it takes a lot of the simplicity and efficiency that C also uses. Oh, we've got a LinkedIn user who says, tuning in from the East Coast as an early morning DevOps engineer. I love that. Yeah, right. So the only programmers who are awake right now in America are the ones who are required to be by their job. I am Jay Ching, tuning in from Twitch. Hello, Jay. Good to see you. I've been doing a lot of work on those free tier clusters that you set up. Jay set the groundwork for a lot of our new Cockroach Cloud free tier product, which is what I'm currently working on. And that product is it's a free forever. It's in beta right now, but you can try it out. And it's a free forever version of Cockroach Cloud. It's the power is limited. It's like 1 CPU and up to 5 gigs of storage. But if you want to try out Cockroach Cloud for free, it's actually really awesome because you can just sign up and it takes less than 30 seconds to get a free tier cluster set up. We got Dr. Guy Savage says 9 a.m. isn't that early. I don't know. It's up. That's a matter of opinion. Kajal is tuning in from the US. Alex Niederberg from LinkedIn also tuning in from the US. I guess we can have an argument about now whether 9 a.m. is early. I would say, I think a couple of years ago, I would show up at work at 10 a.m. LinkedIn. We got someone Huang tuning in from the West Coast. I'm impressed by that. Right now it's 6:09 a.m. in the West Coast. Large Data Bank says, sign up on cockroachlabs.cloud for everyone watching from home. Free. Get thyself a cockroach cluster. I need to figure out how to actually. So maybe I need to I'm still new with this commenting system. I haven't figured out how it decides what comments to show, so I apologize with that. But Kajal says demo. Do you want to see a demo of Cockroach Cloud free tier? Kajal has moved from 10 a.m. to the 5 a.m. club. It feels good. I like waking up earlier now because, I feel superior to those who wake late. That's really the main reason I do it. Ranjith from LinkedIn tuning in from India. So I guess it's in the evening. This is the bedtime stream in India, maybe. So we got right. I believe that the place we stopped here was test coverage. So the goal is not to have as many tests as possible, but to be confident in your code base. Yeah, that's great. So every test has a cost. Yeah, that's definitely true. Any test that you create, you have to also update and maintain. So I think that's very true. So we don't really need 2 tests. Right, so let's actually first pull up the code from the previous exercise. So we've got this function sum. Really, this is just, it's initializing a new some total variable and then adding everything in nums to it. And then I think what they're more talking about here is sum test.go. We have 2 tests where we're testing a collection of 5 numbers, but we're also testing a collection of any size. And I think what they're claiming here is that we have enough test coverage already that we don't actually really need both of these tests. I think that that's true, but I don't know if you can totally go on the line coverage. Let's just go with their philosophy. But right, so they already say here is having 100% coverage should not be your goal. It's just a tool to give you an idea of your coverage. I had definitely some bad experiences with some contractors where I think we had in the contract that they needed to write code with 80% test coverage, and I think they ended up doing some kind of weird stuff to kind of artificially boost their test coverage numbers. Eventually, actually, I think they just stopped rerunning the function that measured the test coverage, and then they hoped that we wouldn't notice. That was a pretty crazy time. So I'm going to run go test -cover. I think I might go into the sum directory. I've actually never tried this go test -cover before. So let's see what it spits out. Coverage, 100% of statements. Wow, amazing. So now we're going to delete the test and check the coverage again. One thing is, I don't know. I don't think that test coverage, just because you have 100% test coverage doesn't mean that your code is 100% tested. It's still possible that there's weird cases where you have 100% coverage, but it's possible for something crazy to happen. Does that sound right? Is there a way, would there be an easy way to show code on this stream that has 100% coverage yet has some kind of weird bug or crash in it? I think I want that to be my goal for now. I want to, so which test do they want us to delete? Oh, they just say delete one of the tests. I'm going to go ahead and delete this first one, sure. So what I want to try and show is, it's kind of a little puzzle. Can we get 100% test coverage yet have a bug in our code? I'm curious does anybody have ideas for how we could create a bug while still having 100% test coverage? Yeah, so time to commit this one. I'm going to run a git diff first, and that shows what I modified, and then I'm going to do git commit -am, remove redundant test. The git commit -a adds all the files that I've modified, and -m will let me put the commit message right on the command line. D. Hartunian says, some kind of overflow, a nil value passed to a function that you didn't test for, but got line coverage credit. I like that a lot. Could we do, what if we did in our sum function? So I think one thing, I don't know if we even need to. Yeah, how can I cause this to overflow? I actually think this particular function wouldn't overflow, but maybe I'll make a new function to try and break it. So func, I could just try index, and then I could take in the numbers and an index, and we can hopefully make this overflow just by returning by choosing an index that's out of the bounds. So I could just do return nums, and then I assume we can just index with index, and maybe that can break it. Let's see. So the first goal here is to get 100% test coverage without anything breaking. So I'm going to call this like a good index because I'm planning to have the index be fine. It'll be within the bounds of the array. And so let's make a new array. And I really only need, I don't know, I only need one element in this. I'll just put 1, 2, 3. So I'm going to call this function got. And I'm going to call, I forget what I called my function, but I'm going to start with the 0th thing, with the 0th index, and then this should return 1 because that would be the, in normal human language, first element of the array. Oh, we got Paulo tuning in from Brazil. This is a very international community. I know. I guess Cockroach has a pretty big international fan base. Still, pretty cool to see all the different countries that people are tuning in from. I think we got at least 3 continents at this point. So that's pretty good. We should set a goal to have one viewer from every continent, except for Antarctica. That will be the stretch goal. I was just reading about this runway on Antarctica. It's made out of ice, and they cover it with snow in the summer to keep the runway from melting. Sounds pretty cool. Pretty dangerous, I think. So let's try running test index. Oh, I think I'm missing a closing brace here. So let's try running test index. And what we want to see here is 100% test coverage. I think I probably called, oh, okay. I'm going to call this IDX just for consistency, and so it doesn't crash. Okay, yes. So this is great. We have 100% test coverage. So now the question is, we have 100% test coverage. Does that mean that our code is 100% tested? LinkedIn user says they only use R on Antarctica. Science in the cold. I like that. Unfortunately, in my in my comment feed, it just says LinkedIn user. For whatever reason, the LinkedIn plugin doesn't have people's names. So if you want to tell people your name, you're welcome to. But it's not because we don't like you. It's just because I guess this comment plugin just says LinkedIn user. So all right, let's tune out of this. So yeah, I want to crash this now. And what I'm going to do here is I'm going to index with index 4. And I'm pretty sure this is going to crash the function. So I'll just run go test. Yeah, so that's really cool. So what we learned here is just because Go says that your code has 100% coverage, that does not mean that your code is 100% tested. I think that that's a really important distinction to know about. Coverage is a really good heuristic for how well your code is tested, but as we can see, it's not too hard to contrive an example for a code that's 100% covered and still has some kind of weird edge case. So D. Hartunian, thank you very much for the overflow suggestion. That was a really good way to do it. Ooh. Okay, so we need a new function called SumAll, which will take varying number of slices, returning a new slice containing the totals for each slice passed in. Okay, cool. So I don't actually want to keep this. I don't want to keep this broken test because that was just kind of a fun experiment. I'm going to do git stash. I don't know. I could have just done a git reset, but I'm sentimental about that code. What if I want it back later, you know? So here's the test. I'm going to just paste this into the test file. Are people used to working in languages that have variadic arguments? This is like, you can put in as many arguments of a particular type as you want. Felipe says, can you zoom in a little the code to be more easy to read? Yeah, I can try that out. I'm going to go into 2 zoom levels. Let me know if that works well for you. Thanks for pointing that out. That's really helpful. I'm also going to zoom in a little bit the text of the book so that kind of matches. But yeah, thank you so much. If you can't see something, yeah, please let me know. I hope that's a little bit better. So let's see. I want to go to SumAll now. So we can pass in any number of lists to this. That's pretty interesting. Honestly, these variadic arguments in most languages, I don't know, they kind of make me like a little bit nervous. Do people like this feature? I don't know. Does variadic arguments make you nervous too? I can't exactly articulate why, but something about it just seems weird to me. So I'm going to go to sum.go, paste in. They've kindly given us the signature of the method, but they have not given us the code. So I think we're going to have to write a nested for loop here. That shouldn't be too advanced, I think. So I'm going to call my inner thing numbers. Numbers to sum. I guess I need to create a, I think I need to create, oh, you know what? I don't actually need to create a return value because I believe that, yeah, we've actually, in the function definition, this creates a new variable called sums that will be an empty list of ints. So that's actually perfect for us. That's a feature that I've only seen in Golang, but I think it's actually really nice because a lot of the time you need to create a temporary variable and then you later return it. So Golang makes it super easy. Sura C10, welcome. Thanks for tuning back in. So, all right, we need to do an inner loop here too. B. Hartunian says, what's the advantage of variadic arguments over passing an array of the same arguments in a single param? Do you avoid allocating the extra array? I don't know. I suspect that under the hood it works. I suspect under the hood it is like an array. I don't think it's about performance. I would guess that it's just like an ergonomic thing. The question is, do you think that a function that can take a variable number of arguments is ergonomically good or ergonomically bad? To me, I don't know. It just makes me Makes me a little bit uncomfortable. I like to. I bet it also makes it a little harder to write like IDEs and to search through your code. So I'm going to create a new sum here. Oh, hold up. Can I actually call my sum function within sum all? I feel like that's an incredibly basic thing to do, but yeah, I think I can do that. So let's try using sum here. So I'm going to do sums, and then I'm going to do a plus equal, and I'm going to call the sum function. Wow. I was like kind of starting to rewrite the entire sum function before I realized that probably we can just call it. That's the great thing about programming. Sora-C10 says, for my Rust brain, variadics are bad, and code that uses them should either take an array or be a macro. Yeah, that sounds about right. That's kind of my intuition. I'm not saying it's right. I'm just saying like that's what my brain thinks as well. LinkedIn user says, maybe variadic args are a replacement for optional args or lack thereof in Go. I think the difference between variadic args and optional args would be that for the variadic args, you actually need them to all be the same type. But for optional args, potentially you want to have a finite number of them, and you might want them to be different types. So it's almost like the difference between like a list and a tuple or something like that. But I think you could use them as a kind of optional arg, maybe. Do I need to actually write return sums here, or will it like automatically know because I declared sums up here that I need to return sums? I'm going to try commenting it out and seeing. I'm guessing it won't compile. I'm going to write go test. Okay. So invalid operation, sums plus equals sum of numbers. And then we've got a mismatched type, int slice and int. And I am missing a return at the end of the function. So I'm not allowed to comment this out. We need to explicitly say what we're returning. Okay. Let's see. So why is this a mismatched type? Oh, this plus equals is not an append. I need actually an append operation here. So Sora-C10 says, I've also struggled with writing bindings to a C library, which kind of abused them. Ooh, interesting. Yeah, right. I think that like C is C is a super simple language, and that's what makes it kind of the like lingua franca of, you know, when you're communicating between multiple programming languages, C is kind of the standard. But yeah, it's weird that it has variadic. I didn't remember that it has variadic arguments. So let's see. Shep, have you tried meditation? Compliments my beard. Thank you, Shep. I've been growing the pandemic beard. So let's see. I'm trying to do a plus equals, but I really need an append. I think I do something like append and then pass in sums, and then the thing that I want to append onto it. Let's see if that works. Okay, line 23 in my test. Shep, have you tried meditation? Says, are you on vacay or do you not work Fridays? So I think you're probably tuning into my personal Twitch stream. What I'm actually doing here is I'm streaming on behalf of Cockroach Labs, which is where I now work. So Cockroach Labs, for anybody who's just tuning in, uses Golang for pretty much everything. And so this is my stream of learning Golang. And it's pretty awesome because I get to stream learning Golang every Friday. Cockroach has this thing, Flex Fridays, which is like you can use your Fridays how you essentially, if you got something on that you think is useful for you, or if you just want to take your Fridays to maybe take a breather and do some self-care. That's something that Cockroach Labs encourages you to do. And I think that that's really awesome. Yeah, I don't know. I don't think it's bad to do a little swearing at a work event. I mean, I was actually kind of worrying if somebody from my personal Twitch account would say something like completely insane about my personal life on the stream. But I don't know. I don't think it's a big deal. Should we rather watch your personal stream or the Cockroach one? I don't know. I'm not sure if it even really matters. I think I don't have an answer for that. Part of the point of this software that we're using called Restream is that, as you can see from the comments, the stream is actually going out to Twitch on 2 accounts, YouTube, Periscope, LinkedIn. So you've got people tuning in from a bunch of different platforms. And I think that that's actually really cool. The white shirt, hoodie, and beard kind of has the Obi-Wan, Ewan McGregor vibe. Oh, thank you very much. Yeah, I would say that. Oh, watch this though. Here's my Jedi. We got the Jedi hood game going on. Yeah, my fashion is about 95% inspired by the Star Wars universe. So I appreciate that compliment very much. So line 23. Okay. Oh. Okay, so I guess we were supposed to get that error. You don't need generics. Yeah. So, okay, they wrote a test, and I guess the test was not correct. Oh, fascinating. Go does not let you use equality operators with slices. That is I'm going to say that's kind of annoying. I think I see why they're doing that, because they're probably saying you want an equality operation to be constant time. And if you're doing equality operations on slices, then it's actually linear time in the length of the slices. So maybe that's why they're saying that the equality operator doesn't work on slices. Does anybody have a perspective on why Golang won't let you do equality on slices? I would say, does C let you do that? C probably does not let you do that because you can't overload operations. One moment, I got a urgent email. I'm going to respond with the text, great. Okay, sorry about that. So yeah, I don't know. My guess is that they're trying to keep everything constant time. Have you read the article about O of n squared JSON parsing in GTA due to scanf calling strlen? No, I saw people on Hacker News complaining about scanf, but I didn't really look into it. I actually don't really know what scanf or strlen is. A Werner 32 says equality operations aren't supported on lots of type. Like you can't do equals equals on functions. Yeah, that for functions it definitely makes sense because like what even would equality for a function be? That seems hard to define, but for something like a slice, it seems kind of like there's one unambiguous semantic meaning at least that equality over two slices should have. Like I would check, they have to be, they would have to be the same length, and then each element would have to be equal. A Werner 32 says, and then what would equality for a slice of functions be? That's a great point. I think you would only be able to do equality checks for a slice where the like the element of the slice could also have equality checks on it. Large Databank says, could it make sense for the Go equality method to always do the simple by value comparison? Like this slice has the same length, capacity, and pointer. Oh, interesting. So you're saying that would actually be, that's kind of what Java uses, but I feel like that is like a pretty big foot gun in Java because, oh yeah, okay, it would be confusing but consistent. Yeah, because what happens in Java is a lot of people will try and compare like two variables that have the same value but different locations in memory. One thing that can make it even crazier is if you're looking at something like string interning or like interning of any kind of value, it's hard to tell when two variables will or won't have the same pointer. A Werner 32 says, like, should int of 1 and 2 equals int 1 and 2? With your proposal, no. Well, so that's actually really interesting because I think would the Golang compiler see that those are two, like, would it see that, oh, like these two things are the same value? I'm going to just put them into one location in memory so that it would actually return true. But I think the problem there is like, as an end user, I probably shouldn't have to know how the compiler is going to do that. And the compiler should be free to change whether it will actually put those two slices in the same point in memory. Or maybe there's some guarantee in the Go compiler that I obviously don't know about because like maybe it will say, oh, it always will create two separate slice literals. It'll never try and combine them. I mean, for me, I would say I would want int of 1, 2 to equal int of 1, 2. Just like intuitively, that sounds correct to me. So, okay. We could write a function to iterate. Yeah, I think we have the skills to do that. But for convenience, we can use reflect.deepEqual. Cool. I actually like the solution of just not letting me do it more than I would prefer a situation where it does just like reference equality. So, because it keeps me from doing it keeps me from doing the foot gun that you see in Java. So I'm going to do reflect.deepEqual got and want, and I think We should be okay to go. Oh, I need to import reflect. Cool. I think this is how I do it. Ooh, reflect.deep equal is not type safe. The code will compile even if you did something a bit silly. Oh, I love this kind of thing. Ooh, yeah. So it will let you compare a string that says Bob to an array. Now, I'm going to guess it returns false for that, but do we think it's possible to get reflect.deep equal to return true for two values that are of different types? That would be pretty fun. If there's a way to do that, definitely mention that in the comments. LinkedIn user says, apparently slices can only be compared to nil. Oh, that's cool. I see. So anything can probably be compared to nil, I'm guessing. Does 0 equal nil in Go? I feel like it should, based on nothing. A Werner 32 says, no, not anything can be compared to nil, just reference types. So an int is probably like a value type or a primitive or something like that. A Werner 32 says, reference types are slices, functions, chans, pointers, maps. Okay. Are user defined structs also reference types, I would guess? We haven't gotten to structs yet, so I don't know yet. I'm not going to try out this Bob thing, but I do love it. Structs are value types. Their pointers are references. Ah, very cool. That makes sense to me. So when you make a struct, it actually, will it go on the stack rather than needing a new allocation? That would be pretty cool. Oh, A Werner 32 says, depends on escape analysis. Very neat. Oh, okay. So I think, what are we doing now? We're writing code to make the function pass. Oh, yeah. Okay. So their code is better than mine. Because the reason that their code is better than mine, what they're doing is they are first measuring the length of numbers. Then they are allocating an array. Let's pull up my code side by side. They're allocating an array once at the start. And then they're assigning each element. Whereas for me, I'm actually appending. I'm repeatedly appending. Can anybody in the chat confirm that doing this append operation will cause an allocation to happen? My guess is that this will actually allocate for every call to append, which is bad because allocation could result in a syscall, which can add overhead to the program because we're asking the operating system for more memory. Amortized allocation. Have you learned about cap? Well, I'm currently learning about like slices. So I bet I don't think I'm at cap yet. It would be cool. Oh, slices have a capacity. Perhaps we are about to learn about cap. Let's see. Yeah, maybe we can get to cap here. So I'm going to see if, are we committed to Git? No. So this is sum all. And one thing I've got here, I have a little Git hook that will run all the tests. I like that because it keeps me from accidentally committing broken code. So let's see if we can push on through cap here. If you have a slice with a capacity of 2 and try to do my slice with index 10 equals 1, you will get a runtime error. Yeah, so we actually saw that. SourceC10 says, wait, so slices are basically vectors in C++/Rust. Are they vectors? Because you can can you resize a slice? For context, in Rustlang, a slice is pretty much only it's like a pointer to a section of memory. You might be able to you can if you have a mutable slice in Rust, you might be able to mutate the data in that area of memory, but you definitely cannot do anything that would cause a new allocation. So I actually had thought that a Golang slice was kind of like a Rust slice, but I think it's more like a vec in Rust. Yeah, I think that this Restream platform is actually really cool, but it might take a little while to get used to because so I can see everybody's comments, but depending on what platform you're on, you can only see the comments that are on the same stream that you're watching. So if you're on if you're on the CockroachDB Twitch stream, you won't be able to directly see the comments that are on my Twitch stream. Werner32 says, yes, they're a lot like vectors. Append may resize. A slice is and then we've got a struct with a capacity, length, and a pointer to the array. Werner32, thank you so much for these detailed Golang explanations. This is super helpful because I did not have the right mental model of a slice. So it's really helpful to have your explanations. Right. Yeah, you guys can. Yeah, I turned on the comments on Restream, so you can see them on Restream. Okay. So okay. So this is actually the code that I wrote. My guess was that this code is worse because append will cause too many allocations, but it sounds like it's more like an array list in Java where it will it'll do fewer. It won't do one allocation for every append. It'll allocate a new segment of memory so that you only have to do, if you add n elements to the slice, you'll only need to do log n allocations, I believe. And I think that's Werner32 mentioned amortized allocations. I think that's what that's the official term to describe that, because each allocation can help. Each allocation helps you do multiple append operations, so it's not a one-to-one correspondence, which is great. Okay, so now we're going to try and change sum all to sum all tails, where we're going to calculate the total of the tail of each slice. This is actually a very, to me, this reminds me of functional programming. SourceC10 says, Go doesn't have to differentiate between owned and shared types, I guess, since it's garbage collected. Yeah, in Rust, there's a lot of effort that one needs to put into thinking about ownership of types, but Go it takes care of all of that for you, which is, it's definitely nice in a lot of ways. So let's write or rather copy paste the test for sum all tails. Cool. So let's see what this is doing. we've got two lists. Each has length 2. And here it should return 2 for the first list and 9 for the second list. This is kind of a weird, this is a little bit of a weird example because lists each have length 2. I feel like we might want one with length 3. Like I'm going to put 0, 9, and 4. And I think this one should return 13, let's say. We're not actually really doing, we're only summing one number for each of those. So let's try and write the function now. What I might do here, I'm going to copy sum all. Ooh. So I wonder actually if I can like take a sub slice of each of each of my number arrays. So I remember that if I just do colon, I would take the slice of the whole thing. So I'm going to use my new Golang rule, which is if you don't know Golang, just write Python and see if it works. And in what this would do in Python is this would take a list of, this would take every element except for the first element of the list. This could be a problem if the list is only of length 0. That might crash it. I'm curious to see if that will crash it. SourceC10 says, is there a reason you have syntax highlighting turned off? I think it's just like I'm using like the stock Vim that comes with the computer. So it like doesn't have anything installed on it. I should get one of those awesome Vim plugins because syntax highlighting would be pretty nice. For the actual Cockroach work that I do, I've been using Golang. I've been using Golang, which does syntax highlighting, but I thought it was like kind of overkill for this tiny a project. A Werner32 says, Go format with Go imports will make your life better. I am ready for that. Go format is, do I have, or do I actually, okay. So I'm going to do man go format. Nope. I'm going to do maybe just run this. I don't know about that. Doesn't seem to like that. How about -H? How about go from it and then path? So I probably do want to write to the current files. Just run go from it. Okay, let's do that. It feels like it's hanging though. Like it really shouldn't take this long to, I have like 4, well no, I have 8 files in this directory, but they're like, each file is like less than 50 lines of code. So it reads from standard in by default. So I think I want it. Oh yeah, there we go. So I'm going to do go from it -w and then dot. And then I'm going to run a git diff. What did go from it change? It definitely fixed some of my indentation here. I think that's a big thing that it did. It might have actually rewritten my spaces to tabs. This book uses spaces, but I believe at Cockroach we use tabs, and I think that tabs are the normal thing for Go. So can I just, I'm going to do it. I'm going to, yeah, let's just commit that. Go from it. Thanks, A Werner32. And I'm going to have to turn on no verify because my test sum all tails is not going to pass. And actually, one thing that would be pretty fun is I could even put go fmit into my Git hook to check that all of my code is perfectly formatted. So are we using tabs now? I think we might be. Vim is confused. So let's see if we can just do syntax on. Oh yeah. See, I'm not that good at Vim, but thank you for the suggestion. Now we've got some syntax highlighting. Oh yeah, so it turns out the Python rule may have worked. Let's see if the Python rule worked. Oh, I love that. Yes, it works again. So slices can be sliced. And if you emit one value, the value on one side, it'll get everything. So we've emitted the value to the right of the colon. That means it'll take everything until the end of the slice. That's great. Go get star 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 to get yourself go imports. Go get star star star. I might need to be in the root of my project or something. I'm guessing. Yeah, I think the package system, like the package and module system of a new language, can be a little bit tough to learn. I'm not sure what I need to do for these Go imports. Import path does not begin with host name. Oh yeah, I probably need to put this in my Go / this is not on my Go path properly. I think that's the second time this has been annoying. So I gotta put this project onto my Go path when I have a moment. So we did the tails. Oh yeah, and then safely sum empty slices. So this was something that I was a little bit concerned about. And it turns out this indeed is a problem. We're trying to take the slice, we're trying to take a subslice of an empty slice, and we're getting we're going to get an index out of bounds. I think the other thing that you could see is, I don't know, it could let you just do that slice and return an empty slice. That might be a little weird. And I'm going to just actually copy this entire func. That way I don't have to re-tab stuff. I'm sure there's a fast way to re-indent everything in Vim. And I'm sure I've done it before, but I don't remember it. Hey, Werner32 has completely given up on me being able to get Go imports. We'll figure it out in the future, though. Probably not on the stream. I haven't really learned about the module system yet. I think, yeah, having this project in the wrong directory also messed up the Go doc. The test has compiled, and we get a runtime error. Okay, so they're writing an if-else statement. Is this I don't know. I guess you can do it like this. That seems fine. There's probably a bunch of other ways that you could do it. Yeah, this seems like a pretty reasonable and uninteresting solution, because we're explicitly checking for the edge case rather than, we're not trying to find some perfect snippet of code that will handle both the edge case and the original case well. So let's do that. Have this baby over. And else. Oh, I think I have this clause in the wrong section. So I need that down there. SourceC10 says, if you put syntax on in your vimrc, it will automatically be activated. Ooh. Yeah, I'm pretty sure I don't even have a vimrc yet, so that's something that I should get if I'm going to be streaming on, or I'm going to be streaming with Vim. So their code is actually a little bit different. They create this tail variable, but I don't do that. I just put the tail, I put the slicing right inside of sum. That's just a matter of preference. Their code maybe is one line longer, but perhaps a little clearer. So they want to pull out this checksums test helper function. I don't know. That doesn't seem that interesting. I'm probably just going to skip that unless people think that that's like a cool thing to do. Let's run the test though. So now I'm going to make a commit tail of empty slice. Oh yeah, so this is actually great. We have managed to wrap up arrays slices, and we learned some fun things today. What did we learn today? So we learned how to slice a slice. We learned that a slice is kind of like a Java array list or a Rust vec or a C, I think it's called vector, where it actually can resize itself, which is very convenient. Oh, interesting. When you take a slice of a slice, does anybody know, does the slice of the slice point to the same memory? Like if you modify one, does the other automatically get modified, or does it like smart? Is there a smart copy? A Werner 32 says yes. So the slice of the slice should point to the same memory. That sounds like a pretty fun thing to play around with. So I think we're going to be signing off. What's the next chapter? The next chapter is Structs, Methods, and Interfaces. Cool. So this is where we're going to be actually defining our own data types and also learning about interfaces. That should be pretty fun. So I'm going to be streaming next Friday, probably at the same time, which is 9 Eastern, or, you know, what time is it in the UTC? I think it's 2 p.m. UTC. So thanks everybody so much for tuning in, and thank you for all the help on, explaining how Go works, how to use my editor, how to do Go format. It's been really helpful, and I really enjoyed learning about arrays and slices today, and I'm looking forward to seeing everybody next week. So thanks so much for tuning in, and hope you enjoyed the stream.